To enhance the accuracy and reliability of my classifier, I employ several techniques that address both data quality and model robustness. One of the major challenges in classification tasks is imbalanced dataset, where certain data classes are underrepresented. To conquer this, I integrate Smooth into my pipeline. This method generates synthetic examples for minority class. Ensure that the classifier does not become biased towards the majority class. Instead of relying on the single model, I tested multiple algorithms, including random forest, XGBoost, LightGBM, CatBoost, SVM, logistic regression, gradient boosting, and neural networks. By evaluating diverse range of the models, I ensured that the final selection was based on empirical performance rather than assumption. Assemble learning and stacking. I also not only check for the F1 score, I also check for the standard deviations. Although CapBoost has lower F1 score, it has lower standard deviation. I choose it as my final model and get a better result. While improving raw performance is essential, it is equally important to ensure that the model generalizes well to unseen data. Here's how I assess and refine my classifier's fit. First is cross-validation with stratified k-folds. To obtain a robust measure of performance, I used stratified k-folder cross-validation, which has 5 folds. These techniques ensure that each folder maintains the original class distribution, reducing variance in valuation metrics. Precision and recall. The second one is precision recall and ROC curves. Since the accuracy alone is not always the best indicator, I analyze precision recall and ROC curves. These metrics help identify models' ability to balance false positive and false negative, leading to better decision making in a real world scenario. The third one is learning curve for overfitting detections. To check for overfitting, I plot learning curves, which illustrate the model's performance on training versus validation data. If the gap was too wide, it indicates overfitting, prompting adjusts such as regulation dropouts layers in neural networks and early stop mechanisms. Feature importance. The fourth one is feature importance and interpretability. Understanding why the model made certain prediction is very crucial. I used sharp values to interpret feature importance, ensure that the model's decision making align with main domain knowledge.